All right, so here's a rectangle class which has setters and getters. So take a few seconds here to this is essentially review what we just learned. There are two properties. So by default, properties are private. So even though the person did not specifically say private double length and private double width, by default, Java makes them private. So you can assume they're private unless they are specifically said to be public. That's bad. I would argue that's bad programming practice. It doesn't hurt anybody to explicitly say that they are private. So that would be better. But anyway, I just want you to be clear that if it says double length, double width, by default, Java makes them private. Then there's the constructor. You can set a length and a width. And it sets them, so that's not a setter, that is a constructor. And then there's two getters and two setters and a toString method that helps you print out a rectangle. So what we want to do here is make our rectangle class a little more useful. We want to have three new methods, one that does perimeter, one that does area, and one that does diagonal. So when we design a new method, the first thing we want to do is think about what does it need to do, right? If we're trying to find the perimeter, that means that it's the area around the edge. And hopefully you remember from 4th grade that the formula for perimeter is basically just twice the length plus twice the width. And those are the only things we need. So because we already have the length and the width, our method doesn't need to be sent any information at all. So the parentheses at the end of our definition are going to be empty. So we could have it return the perimeter, but in this case, to start out with, let's just have it print twice the length plus twice the width. So we know it needs to be public, right? Because we want other people to be able to use it. We're not returning anything just yet. Right? We're just going to print out the perimeter. So we're not sending anything back. We'll just call it perimeter. That seems like a good name because it explains what it does. And we're not sending anything into the method. We don't need, it already has the length and width inside the class available to it, so we don't need to send it any information. So technically, I think you should declare perimeter an integer in here, but this is all it needs to do is print out twice the length plus twice the width. So that's it. That's the entire perimeter method. So the 3 steps, right, to creating and using a method are you have to write the method, obviously. And the second step, the reason I want to make this explicit is this is often people forget this part. In the main method, when you're running your program, you have to create the object. For almost all methods, we're going to get to other types later, but for almost all methods, you have to run it on an object. That's what quite a few of you were missing last time. You need to create an object and then say that object dot method name. So if we want to get the perimeter of a rectangle, first we write the perimeter method, but then we have to actually create a rectangle object to call the perimeter method on. If we don't create that object, we can't call perimeter. There's no perimeter if there's no object. So you have to create an object to call perimeter on it. So say this is our main method. You're going to create a new rectangle object with a length and a width. And then you have to say R1 dot perimeter. You have to call the perimeter method on that object you just created. You can't just call perimeter because it won't know where to get the values from. So twice 10 plus twice 17 is 54. So I would like you to, in the chat, write a area method. So you're going to have to figure out who's going to access it. Is it public or private? Let's just print out the area so you don't need to worry about returning anything. Come up with a good name for it. Figure out if you need to send any data to it. And then print the area and figure out if you need to return anything. So I'm going to give you a minute or two to come up with a method that prints out the area and does not return anything. All right. Hit enter. So you can edit or re-enter a new version of your answer if you've been reading other people's. So in this case, he changed the definition to a double length and a double width. And then in the constructor, he has int length and double width. So he's a little bit confused. So I'm not going to be concerned about whether you said int or double, but just so you know, on the actual exam and in my exams, they will be consistent. I'm okay with either one. I'm not worried about that right now. I'm more interested that you get how to write a method. So it looks like most people are getting it here at least. You need public because everybody needs to use it. You need void. Well, this time you changed it to returning. If you're printing, it's void. If you're returning, it's double. All right. We're not sending anything. And again, he didn't declare his variable area, so he should have said double area equals length time width. I'm becoming less of a fan of these slides. But anyway, point being, in this case, he didn't print it out, he returned it. So that's why it says public double. So those of you that decided to return it, that's fine. Again, I'm more worried about that you understand how it works than that you got perfectly right now. If you printed it out, you should have void area. And if you returned it, you should have double area or int area, depending on how you calculated it. So again, this is how you would use it. In this case, though, remember he returned area. He didn't print it out in his method. So if you just say r1.area, it won't print anything out because we didn't tell it to print anything out. It just returns the area. Right? You'd have to actually print it unless the method prints it itself. So when we did perimeter, right, it printed it out for us. Here, the area just sends back the actual area, so we have to print it out ourselves. So just two different ways of doing the same thing. It's fine. I would say that in most cases, you want to return the value, not print it out, because generally you want to give the other programmer the option to do whatever they want with the area. If you just print it out, they can't do anything with that. So usually returning it is the right answer. All right, so in this case, I don't want to spend time on this, but basically, if you want to think about it, you're for the diagonal, you would have to use Pythagoras to take the square root of the length squared plus the width squared. So it would look something like public double diagonal return would look something like that. All right, so I'm not going to go through this right now. We don't have time, but you can, kind of think to yourself what would be involved in creating a circle class, setting the diameter, getting the diameter, radius, circumference, area, things like that. So that's what we are going to do for methods. Okay, so I'm going to continue on. Talked about commenting, so I want to go to about. One thing I do want to I just want to make a note on vocabulary. You probably heard me say the word arguments instead of parameters for what you're passing into a method. So hopefully on the AP exam, they will be very, very explicit and they'll use their language properly. A parameter is what you define in your class. So that is technically called the formal parameters. So when you define your method, like in your setters, your mutators, you have to include a parameter. You have to include a variable that you're passing in that you want to set to your, that you're sending to your class. So you set a property inside your class. So a parameter is how you define what variables are getting sent in to your method. An argument or an actual parameter are the values that you send in when you're using the method. So the parameters, the formal parameters, are what are in your definition, in your blueprint, in your class. And then an argument is something that you actually use in your method. So those are the formal definitions. A lot of people use them interchangeably because they're basically the things that you're sending into your method. But technically, they have different names. So I just wanted to be clear about that. All right, I don't want to spend time on that today. I think we have done enough on that for today. All right, so if you remember, hopefully you remember, all Java programs have a main. All right, so let me start a REPL here and I'll share it with you. So here's your main program. And I kind of waved my hands and said, don't worry about what public static void main means. Right? If you remember, all the chapters up until now, basically, I just kind of waved my hands and said, trust me, it works. Well, now you know what public means, right? Public means anybody in the world can run my main, right? I just ran it myself. There you go, run. So anybody can call this method. It's public. And we know what void means. It means it doesn't return anything, right? If I try to say return something, Java will barf and say, you can't do that in a method that is declared void. right? Unexpected return value. Make this bigger for you. Right, so I can't return anything. It doesn't matter what I try to return. I think I can return nothing and it'll work. But if I try to return anything at all, Java will barf because I declared it as void. And then we know what the arguments are here, parameters, because this is a class definition. We know what the method name is. The only word that we don't know in this whole program anymore is this word right here, static. So what does static mean? Whoa. So there's two parts to this. There are static variables and static methods, and they're slightly different. So a static variable belongs to a class and not to each individual object. So this is the key. When you put static in front of a variable name, it exists inside every single object you create, the same value. So up until now, when I had a person or a car or whatever, if that person had a name variable inside it, that name variable was unique to every single object. Every single object had its own name, its own email address, its own phone number, blah, 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 blah. Every car had its own type, its own color, its own mileage, blah, 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 blah. But say, for example, I want to keep track of the total number of people or the total number of cars. If I just have a variable called num people or num cars, that number is going to be different in every single object. I want to keep track of the total number of all the people objects that have ever been created, and all the cars that have ever been created. What I can do is create a static variable, and that variable will be shared among every object of this type. If I add 1 to that variable in my minivan car object, 1 is added to that variable in every other car object that exists in my program. So you can think of it like this. If I want to keep track of total number of cars, then in my car constructor, I could just add 1 to a static total number of cars. And every time someone calls that constructor, I add 1 to the total number of cars. And every car in the world can say, oh, what's the total of number of cars now? Just look at that static variable, because it is constantly updating every time a new car is created, and the value of that variable is shared among every object. So it's both really powerful and also really dangerous, right? Because you can change that from any object. So in our person class, right, if we add a static person counter, and in our constructor, we add 1 to that variable every time, then that person counter will always go up by 1 every time a new person is created. In this case, we probably also want to have like a person dies or leaves the company or whatever that reduces the person counter as well, right? Because you don't want it to go up forever. But the point being, static variables are shared among all instances of that object. It'll be the same value no matter which person you're looking at. The person counter will be the same. So give me a plus minus squiggly for static variables. It's okay. They can be tricky. There's no embarrassment in not totally getting it this first time through. It's an example we could use in real life. Imagine you had a magic backpack. And everyone in your school had the ability to create one of these magic backpacks. And the cool thing about the magic backpack is if somebody puts something in it, it immediately appears in everybody else's backpack. So even though you have some properties that are unique, your name, your age, your email address, you also have a backpack property that is static across all the student objects in your school. If somebody puts something in the backpack, everybody has it in their backpack. If somebody takes it out of the backpack, it's gone for everybody. So that's kind of what a static variable is like. Everybody has access, everybody of type student has access to this magically shared backpack, which is different than most of your properties, which are unique to you. All right, so up until now, we've used non-static methods, right? So again, what this means is it's unique to that object. So every object can run it, but you have to run it on a specific object. You can't just run perimeter. You can't just run area, right? We had to create our object first and then run the perimeter or the area on that specific object. And we can change, like setters can, you have to call in an object and they can change the name of a person, right? A setter, right? If you set name, you have to call it on a specific person and you have to pass in a name and it changes their name. That's what a setter does. Static methods can be used just by referring to the name of the class. So you have seen this with random. Math.random is a static method. It means you don't actually have to create a math object, right? We never said math blah, blah, blah equals new math and then say blah, blah, blah dot random. We just said math dot random. So A non-static method is like when we were using the turtles, we had to create a turtle and then do something with it. We had to create a rectangle and do something with it. We had to create a person and do something in it. A static method, you do not need to create the object, right? There is no reason to create an object when you're calculating square root. You just want to pass in a number and get a different number back. It's like a one-way street. You don't need anything. You don't need any properties in there. You don't need any other methods. All you really want to do is send in something and get something back without having to go through creating an object and all that junk. So static methods are like one-way streets. It's like you send it something, you get something back. And that's it. So static methods, right, can't change object properties because, well, it can change static object properties, but not regular object properties. I can't like use math square root to change the length or width of a square. It doesn't make any sense, right? It's just a one-way street that gets something and sends something back. So you could technically call it with your object. So like if you created a static method in your rectangle or whatever, you could still call it with the object name, but generally you don't. So the perfect example of the static method is our main method, right? So if you look at our main method, there's no object, right? Like we didn't create an object and then run main on it. We just said main. We just said the method name and it just runs. So the thing that static methods and static variables have in common is that there's only one copy of it for every single object. So just like I said, the magic backpack, right? We would create, if you wanted to put something in your magic backpack, you would need to create a static method add to backpack, because you would only want one version of add to backpack shared among everybody, right? In order to have a magic backpack where if one person puts something in, it appears for everybody, you have to have a magic method that anybody can use to put stuff in that magic backpack, right? It has to be like one backpack for all objects, one method for all objects. Java will not let you create or not let you use a regular method on your static object on a magic backpack. Or you can't have individual people, individual students trying to stuff their individual stuff in the magic backpack. It doesn't work that way. You have to create a method, a static method to access static objects. So that's where it starts getting a little bit complicated, is that once you start using static things, like a magic backpack, anything that accesses it also has to be static. So to go back to our person counter, when we create a person, we set all this stuff up and we add one to the person counter that is shared, a shared variable across all persons. if we want to print out the value of how many people there are in the world, we have to use a static method to print out how many persons there are. You cannot use a regular method to print it out because regular methods cannot access that static variable. You just have to be consistent. That's the bottom line. Static methods and static variables go together with each other. So like I was saying, say you have this, static print person counter. You could not then print out a person's name because it doesn't make sense, right? Print person counter is like part of your magic backpack. The backpack is the same for every single student. If you tried to print name, it wouldn't know whose name you're trying to print. It knows the person counter because the person counter is the same for all the students. It's shared. So everybody that has a person counter can print out the same person counter. But you can't use a static method to print out name or email or phone number because those are unique to each object. A static method has to be able to be shared among all objects. It can't do anything unique. Right? That's not necessarily true for the other way around, right? So if I had a non-static method, I could still access all the variables. So like I can have any method can see how many people there are. So the general rule, and this is not a huge part of the AP exam, so don't worry if you're getting a little confused on it. Generally speaking, you only use static if you have a very, very specific reason to do so. So there are not very many cases in the real world where you're going to use static. There are basically two ways, right? You're only going to use a static variable if you need to share it between all your objects. You have some information that needs to be updatable by all your objects and shared among all your objects, like total number of cars or total number of people. That is a reason to make it static. But it's kind of hard to think of a lot of cases where you need that to happen, where you need a variable to be consistent across all objects. The other case is when you don't really have a use for an object, like the math class, right? There is no reason to have a math object. I can't think of a reason right off the top of my head, right? Math is generally a bunch of procedures, right? You're taking a square root, you're getting a random number, you're computing sine or cosine of something. You're always passing something in and getting something else out. You're never like storing something in a math object, right? The only thing that is stored in a math object are constants, like pi. And pi is the same for everything in the world, right? You're not going to create two different math objects with different values of pi. So pi is a static variable. Square root is a static method. All of these things are the same for everybody everywhere. So pretty much everything in the math class is static because there's nothing stored, there's nothing to change, there's no two different unique versions of math that you need to create. It's always the same for everybody. So if you have a class like that, that is the only other case I can think of where you really need a static variable or a static method. So again, we don't have time to go through this, but you can imagine creating a statistics class. And he creates sort of a artificial count method that just keeps track of the number of times a method is called, right? You would need a static variable called count. And then you'd create some methods that take a value and return a value. And then update the static count variable. So again, I'm not going to make you do this. I think you get enough practice with the 5.7 that you're going to do. But are there any questions on how static works? I know it can be a little confusing. Okay, I'm going to go through 5.8 and 5.9 pretty quickly now because they're pretty, I think they're pretty straightforward. Let's see. And then I'm just going to let you go to work on your own through 5.9 for Tuesday. So there are 3 levels of scope in the world. There's class level, method level, and block level. And scope, all that scope means is where you can use something, like who can see it. So if you declare variables as part of your class, anybody in that class can see them. If you declare them public, then people outside that class can see them. But it's still part of your class. It's still class scope. Anyone inside a class can see public or private variables or methods in that whole class. So that's called class scope. If you write a method, then there could be variables that are only visible inside that method and not to the rest of your class. Right? If I say public void print hello, and I have a string h equals hello, right, this variable right here, h, is only visible inside print hello. If I try to use it anywhere else in this class, it'll give me an error. It'll say, what is H, right? Like if I go up here and try to say H, Java's going to give me an error because it doesn't know, cannot find symbol. Right? It doesn't know what H is because H has a scope of this method only. So scope just means who can see it. Anybody in this method can now see this variable H. If I had declared it up here in my class, I don't know if this is going to work in main. Yeah. But if I had here, let me give you an example over here. Right. If I have this class example here, var1, var2, and var3 are class level scope. So I could use them in any method. A is method level. I can only see it in method A. X, Y, and Z are all method level in method B. I can use X and Y because they're parameters. I can use Z because I've declared it in my method here. So I can't see X, Y, and Z anywhere else, but I can see it in method B. And then lastly, there's something called block scope. So block scope is just for one specific block of code. So that variable I dies as soon as that for loop is over. Right? I can't even do this. Right? This is not going to work because it can't find I on line 17. So even though it looks like I've declared it inside my method, I haven't. I've declared it inside my for loop only. So it only lives inside my for loop. That is called block level scope. So if I say, oops. All right, so now it prints out the I's because it knows that I lives inside this block. If I wanted to make it a method level, I would have to do that. Now it's method level, and this guy down here can see it. All right, it prints out that 10.
We can't see what you're presenting.
Oh, darn it. Thanks. Well, let me do that again. So usually in for loops, right, you go like this. And if I try to run this, it's going to fail because it can't find this second I down here on line 17. This I is declared inside this for loop and only exists inside this. It dies. It literally dies as soon as I exit the for loop. I could do the same thing with a J inside the for loop. Right? It's gonna die again because it doesn't know anything about that J. If I put the J up here, it's fine, because that is method level scope. So that is scope in a nutshell. You have class level, where you've declared class properties or attributes. You can see it anywhere. You have method level, where you can see it just inside that method. And then you have block level, where you can only see it inside the block. Any questions on scope? If it's limited to that block, you cannot. Oh yeah, absolutely. That's a really great question. You can reuse it. Absolutely. And that's actually why we generally use block level, because it is something that you might want to reuse, or something that you're never going to need outside the block, right? So I can declare I twice here. It's going to work because I dies the first time. As far as Java is concerned, as soon as I close this for loop, there never was an I. It erases it from memory. And then so I need to declare it again, because it does, this line 18 doesn't know that there ever was an I before it. That's a really great question. You can reuse that variable. And which is really handy for loops, because then you can always use I. You don't have to like worry about if you had a for loop somewhere else in your program. Great question. Any other questions on scope? Anyone need help with their no scope kills? No? All right. All right, so the last thing, and again, this is going to be, I think, pretty straightforward for most of you, is the this keyword. And all that it means is I am referencing this object. So say, for example, you have a class called cat, and you have a breed, a name, and an age. And when you make your constructor, you also pass in the variables breed, name, and age, confusingly enough. If you just said breed equals breed, that would be really confusing. Java would know what you meant, but by saying this dot breed, you're specifically saying this one in this object right now. So it literally means the variable or the method that belongs to this object. Let me do this AP practice example from your assignment. So consider the following class definitions. You have a liquid and you have a liquid jar. Liquid has a current temperature. It has a constructor that sets the current temperature. It has a getter that gets the current temperature. And then it has a mutator that adds some liquid. So the reason that it passes in a this is because what you're asking it to do is add this specific liquid into a jar object. So in your jar object, it has a total temperature, starts out at 0, and every time you add a liquid, it adds the temperature of that liquid to the total. So it's not like, pretend that this is chemically accurate. It doesn't really matter, right? The point being, you have this jar that contains liquid objects, and every time you add a new liquid, it increases the temperature. So you want to be able to have a liquid object and add it to a jar. And the way that they do this is they say, create me a liquid, water and milk, create a liquid jar, and then the water object, add it to jar J. The milk object, add it to jar J. And so the way that it knows to add, this is a terrible example. Why did they do it this way? Anyway, the way that they know how to add this specific object, the water object, to the jar is they call the add liquid method with this. It's such a backwards way of doing it. This is a terrible example. Any reasonable person in their right mind would just call J add liquid water, J dot add liquid milk. This is a terrible example, designed just to confuse you. I like this example better. This is more realistic. This is where you would actually use a this keyword. You want to make sure to be clear about where you're storing the breed. You're storing it in this object, breed. Where are you storing the name? In this object, name. So again, not a huge part of the AP exam, not used a whole lot, just for clarifying purposes like this. You're not gonna really see a lot of questions like this one, this over, where did it go? Wherever. Anyway, the overly convoluted. Yeah. Anytime you're using an object's attributes, you can put this in front of it just to be really, really clear, right? So in this example where I have a string H, I have to do it that way. Static. Right. I can either say H just like that, or if I want to be super, super clear, oh, that's not going to work, is it? I hate Java. It's not going to work in this main program because this doesn't work with static variables because there is no individual static variable for an object. So it doesn't make sense to use this. This only works with variables that are part of the object. Like in your person class, you could say print this dot name instead of just saying print name. don't have a good example. But it's pretty rare to use this. It's just, you might get a question on like, on this example right here. All right, so that was chapter 5 in a nutshell. I'm going to have you do all the exercises over the next 4 days, pretty much on your own. So I know it's a lot of work. I know it's hard. I'm available on Discord pretty much 24/7 when you get stuck. And there are also, other people on Discord as well. But we have to get through this stuff in order to be able to review everything in time for the actual exam. All right, so any questions